Therefore, we understood the sinusoidal signal represents the electrical quantities like V, I, etc. along a time axis showing its instantaneous amplitudes or values and the phase information. So, for any sinusoidal wave, we will have one time axis or omega t axis. So we can tell it omega t axis, or we can convert it to the time axis. So we can get a signal as V equal to Vm sine omega t. Now the axis can be taken as per our requirement or convenience. So if we take the axis as omega t axis, then we can get some major distinguished point, what we are going to study now. And if we are converting the axis with different parameters, then also we will be able to get the similar major points. So here first graph has been drawn with the horizontal axis as omega t, and we will see that the starting point is nothing but 0, and as omega t is nothing but the radian, so this will be pi by 2 radian, this will be pi, this will be 3 pi by 2, and this will be 4 pi by 2 or say 2 pi. 1 we earlier pi 2 pi by, so it is so definitely this point will become pi by 2 omega. This point was pi, so it will become pi by omega. This point was 3 pi by 2, so it will become 3 pi by 2 omega, and it was 2 pi, so it will become 2 pi by omega. So like that we can get the major points of the t-axis. Now we can convert this time to its time period also. So if we scale it with its time period of the sine wave given, so we can again start from 0, and this will be say t by 4, because total time period is this much. So total time period is the time taken to complete a single cycle. So this is t, so this will be t by 4, this will be t by 2, and this will be 3t by 4, and this will be t. Now if we want to convert this point in terms of frequencies, say we can again call the formula of f equal to 1 by t or t equal to 1 by f. So if we convert, then it will become 1 by 4f. This will be 1 by 2f. This will be 3 by 4f, and it will be simply 1 by f. So like that we can change the axis as per our requirement and convenience for any sinusoidal waveform. So we can represent the horizontal axis either with omega t or time period, etc. Now, how one sinusoidal wave or sinusoidal waveform of any electrical quantity is possible to be represented with its phasor diagram? What is the relation between a sine wave and its associated phasors? So first of all, to understand the relation between the phasor diagram and a sinusoidal wave, that is time varying wave, we have to draw the omega t axis. We have to draw one sinusoidal signal like this, though it is not very correct sinusoidal, just hand drawing, so we can consider that it is sinusoidal in nature. And then after that we will identify the maximum values or peak values, because we know that the phasor is representing the peak values of sinusoidal waveform, and we will make another axis, vertical axis, parallel to the main vertical axis, that is amplitude axis. So this is amplitude axis and this is omega t axis. Now we will make one circle. So if you make a circle with the diameter of peak to peak quantity of the sinusoidal wave taken, so this is Vm, if it is a signal V equal to Vm sine omega t, then it will be also Vm, so it will be plus Vm and it will be minus Vm. So now the angle or omega t is varying from the point 0. Now at a particular point, say at this point, if this angle is say phi, then this value will be nothing but the Vm sine phi. So this will be Vm sine phi, and we can get these values in this diagram here if we draw a line perpendicular to the vertical axis here, or if we draw from this point, if we go towards the direction which is just perpendicular to this vertical axis here, and this line will be exactly parallel to the omega t axis. So this value is nothing but Vm sine phi. Now Vm sine phi will be taken from this vector or phase vector if it is considered to be Vm, and in phasor diagram the phasor is nothing but the peak quantity taken from the sinusoidal wave, and each instantaneous values like this will be the corresponding values at their phase points, means angular points. The points, angular points means points along the angle axis or omega t axis. So if this is a angle phi, so this will be Vm sin phi. So this value is nothing but this is Vm sin phi. So like that we can represent the value which is frozen at a particular time, and that time is defined by one angle that is called phase angle, or that instant, the angular displacement from the reference 0 at that instant where we are going to get the value. So this vector or this phasor will be obtained as a rotating phasor along this circle if we move towards in a linear direction along the angle. So this angle is obtained in a circular fashion. So one circulation is nothing but the completion of entire cycle, and that's why it is called a complete 360 degree here. So the radian wise, the peak is obtained as pi by 2 here. If it is starting from 0, this will be pi and this will be 2 pi, and 2 pi radian is nothing but in degree it is 360 degrees. So 2 pi is equal to 360 degrees, like that. So this will be equal to 180 degree and so on. So hope this is clear, that the relation between one phasor and the sinusoidal waveform. So how from sinusoidal waveform of electrical quantities can be represented in a phasor representation. Now here we have listed the major phase points or instants, both in radian or degrees.